Okay, let's continue on and talk about partial fraction decompositions using non-repeating and irreducible quadratic factors. So if I have a quadratic factor in my denominator that cannot be factored any further and is not repeated, I need to include a decomposition term of this form here. Okay, so let's take a look at an example. If I have this rational function that I want to decompose, first thing I need to do is factor the denominator. And this one happens to factor this way. I have a linear factor, a non-repeated linear factor of x plus 5, and a non-repeated irreducible quadratic factor of x squared plus 2x plus 3. So I can write my original rational function as these two decomposition terms added together. And I'm going to continue on with the same method that I was using before. I'm going to take both sides of this equation and multiply both sides by this denominator. Here it is, and here it is. Over here, just like before, this cancels with the denominator, and I get x minus 3 on this side of the equation. On this side of the equation, again, I have to distribute these factors into both terms. The x plus 5 cancels with this x plus 5 when I distribute over here, and I simply get a times x squared plus 2x plus 3. And the x squared plus 2x plus 3 cancels when I distribute to this term, and I get quantity bx plus c times quantity x plus 5. And again, distributing everything in, I'm going to expand it out this way. And once more, I have to, first of all, I have no x squared term over here, or in other words, the coefficient of x squared is 0. And the coefficient of x squared here is a plus b. So I'm going to get 0 is equal to a plus b. The coefficient of x over here is 1. So I'm going to set 1 equal to, 2ax and 5bx and cx. Okay, so 1 is equal to 2a plus 5b plus c, and then I get the negative 3 is equal to my constant terms over here, which are 3a and 5c. So negative 3 equals 3a and 5c. And again, this gives me three equations that I can put into a system of three equations in three variables. And notice I've lined up my variables and my constants in a column. So I can make my matrix, plug this into my calculator, use the reduced row echelon form on my matrix math menu on my calculator, and I can see that A is equal to negative 4/9, B is equal to positive 4/9, and C is equal to negative 1/3. And now I can write my original rational function as this partial fraction decomposition. I can factor out a 1/9 out of both of these terms and make it look a little bit simpler. If I were to add these two fractions together and multiply by this 1/9, I would get this function back again. There's one more item we have to look at, and that is what happens if I have what we call an improper rational function. An improper rational function is one in which the numerator has a higher degree than the denominator. And just like any division that I do, the dividend divided by the divisor is always equal to the quotient plus the remainder divided by the divisor. And that's how I'm going to deal with this improper rational function. I'm going to do the division, polynomial long division. I'm going to get a quotient and a remainder divided by the divisor. And this remainder divided by the divisor is where I can use my partial fraction decomposition.